Good afternoon. So thank you to Meredith and CTIA for the invitation and the opportunity to speak to you today. As Monty Python once said, and now for something completely different. I'm going to do a little bit different, take a little different approach on where we are in 5G. So what I'd like to do is take a look at how we're progressing towards delivering on the full 5G vision. So when realized, 5G will generate about $600 billion of economic growth in the US, if accelerated, according to CTIA. This full vision requires nationwide coverage and application across multiple industries. This is the important part. And the foundations are spectrum, regulatory and infrastructure reform, and standardization. All of us, vendors like Nokia, service providers, and application developers, need this. So, where are we? What's the progress to date? So we've had great progress, that's true. So restoring internet reform order issued in June of last year. The accelerating wireless broadband order issued in January of this year, thanks to great work by Chairman Pai and Commissioner Carr. And over 5 gigahertz of millimeter wave auctions just in 2019 alone. And the presidential memorandum on spectrum strategy. No country in the world has advanced 5G as fast as the US has in the last 12 months. So I'll say it one more time. No country in the world has advanced the case of 5G as fast as the US in the last 12 months. And I check with my colleagues around the world regularly before I make statements like this. So what I'd like to do, though, is take a look at those orders and the millimeter wave spectrum coming available for us and see how they support, or if they don't support, forthcoming use cases. So let's start with the most obvious one, consumer, and I'll focus a little bit here on high-speed mobility. So I thought I'd bring it a little bit home to Washington, D.C. So we've done some pretty detailed studies in Washington, looking at capacity demands today, capacity demands coming in the future, and what are the intersite distances in 4G today. So what we concluded is, if you wanted to provide blanket coverage to DC today with millimeter wave, it would take about 3 to 4 times more sites than what we have with 4G to provide the same coverage. So we think that that's okay. That's within the realm of possibility, meaning it's practically financially, and we can probably execute that. But once we go outside DC to places like Arlington and Bethesda, the numbers go up to 4 to 10 times more, or even much more than that. And that's probably a little bit challenging, meaning probably we won't do that. We'll look at a more tactical deployment of millimeter wave in critical locations. But ideally what we'd like to do is complement that with mid-band spectrum to provide a consistent user experience. So we concluded millimeter wave is absolutely necessary for the forthcoming capacity needs going forward. But we can't go much further beyond the downtown cores, at least not practically financially. So we really need that mid-band spectrum. Another use case, agriculture. So Nokia recently completed a smart farm trial in Iowa. The purpose here was to improve productivity. So what we did there is we monitor plants, animals, and storage bins with humidity, temperature, and motion sensors. And we provide remote control of things like shades, fans, and water pumps. In doing the trial, we also wanted to test 5G in terms of throughput and propagation in a real live environment like this, for this application. So we did that with a single 3.7 gigahertz cell site, and it covered fully the 2.8 by 1.2 mile size of this farm. If we wanted to do that with millimeter wave, it would have taken 15 sites, if not a lot more, and it's not really practical because we'd also have to draw fiber and power across the farm. So in this particular use case, it's very difficult to do with millimeter wave. Much as Ken was saying earlier about, where can we apply millimeter wave in rural applications. Another use case, manufacturing or Industry 4.0. We've done a number of trials with applying 5G in factories in Europe and the US. And the objective here is to improve productivity and increase safety. Factories are really challenging environment because they have a lot of inherent metal clutter. Metal clutter and millimeter wave are not exactly the best of friends. So in practice, for example, we thought, in one example, we looked at indoor coverage area and found that you'd need about 20 times more sites with millimeter wave to do the same factory compared to mid-band spectrum, if indeed you could do it at all. Now, to be fair, I also had some other examples of manufacturing where the pictures look a lot better and you could use millimeter wave, but in many cases you can't. The other learning from this use case is that factories in particular have very different requirements from consumers, quite obviously. For example, the need to synchronize with the factory clock. It seems obvious once you think about it. The need for highly deterministic real-time communications. So when you press the button to stop the line, within 2 milliseconds, there's a reaction. And in general, just the behavior of frequencies inside factories. So in short, we also thought millimeter wave was a bit challenging in some factory areas. So, where are we? As I mentioned at the beginning, we made tremendous progress to date. But we need to do a lot more to deliver on the full 5G vision. The first up is mid-band spectrum. We all know that, it's been said 10 times today. We need it quickly. But we would also have a tremendous benefit if we could receive it in steps. So this is one option we think should be considered. There was a few comments about the race to 5G. So, I've been looking at these myself the last 24 hours or so. So I used to live in China. I used to live in Korea. I know them a little bit. So China Daily announced that Shanghai had blanketed Hongkou, one of the districts of Shanghai, with mid-band spectrum, and a trial had started. Korea announced, what was it, a day and a half ago, just before Verizon, that they had nationwide 3.5 gigahertz spectrum 5G launch. Now, there was some funny articles about calling it a stunt because only 6 celebrities got phones for it, but they were, before the launch just a day and a half ago, they were actually planning to launch Friday anyway, so it's not that much of a stunt. So there's little doubt that the race is absolutely on. Now, the next 2 points are different ones that you haven't perhaps heard before. So there's a lot of talk in the past and recently about the requirement to invest in infrastructure in the US, on the order of $1 trillion. We believe strongly that that investment must include proactive 5G readiness. So what do I mean by that? In Finland, the home of Nokia, many municipalities now, with some encouragement from the government, by the way, when they build new roads, are looking at deploying passive fiber infrastructure at the same time so that when 5G starts to deploy, it can be accelerated. It's 5G ready. This concept you could take and extrapolate to other kinds of bills too. So for example, electrical grids and poles are obvious ones. Maybe bridges or even waterways. So let's call that infrastructure 2.0. Finally, another gap, and I put standardization here, but perhaps I should have called it Industry 4.0. As I noted before, industry brings different kinds of requirements. In Germany, Bosch, Siemens, BMW, Volkswagen are working to get those requirements into 3GPP standardization so that they can lead the race to 5G smart manufacturing. The German government is looking at allocating set-aside mid-band spectrum for vertical industries. Now, it's not so clear if that's the right way to go, but we do know what is clear is that the US in general and US industry need to take action to ensure long-term leadership in smart manufacturing with 5G applied. So, in short, we think that there's been a great start, but if we really want to deliver on the full 5G vision, there's a few other actions that we need to do. Thank you very much.